Hello. Excuse me. Hello, hello. Let's continue. All right. So what happened last time? I think I actually have it in the log. Yeah, so last time we merged this part, or I pushed this part up. Damage numbers, that's right, and hit animation. The little shaky thing with the damage number popping up. Dead state, yes, more monad helpers. Death animation, circle outline algorithm, move rotation option. So that arrows and spells actually rotate towards the target. And then transparent push sprites, and I added also a vim command to create actions. That's right. All right. So that's pretty cool. Also, I did another thing as well now. I changed. So basically, I kind of took. I'm not gonna say it's a final decision, but it's gonna be probably going to be for keyboard only. But you never know. There might be able to do some kind of mobile adaptation or something. I don't know. It's just much easier to kind of think about it in a way. But yeah, what I was thinking now is instead of being able to always hit a monster, you should. I want to add, like, you know, a little bit of randomness to it. So it's like, so I want to make more like, you know, the RPG rules or whatever. And I've no actually idea of doing anything special there. I just, yeah, I just made this little base attributes thing because I thought that, hey, don't all RPGs usually have one of these? And like, I've been thinking about how to actually do kind of the board game rules. And I'm thinking I'm gonna try and use ECS. It's gonna be interesting. Because I think that the most maybe natural way that I would think about would be to do it in just this giant board game struct, maybe, that has a whole bunch of different things. Perhaps, but since things are divided into entities, it would make sense also to use like ECS. So what I'm thinking is maybe have some things that will, like the system, for example, the melee attack system could totally govern what happens with a melee attack, for example. But it's gonna have to look at things like how big of a chance does, like, try to calculate, you know, evasion, for example, if the monster can, or if the target can evade the melee attack or parry or anything else that would kind of, you know, stop the melee attack or something else. So, so there I'm thinking like, yeah, doing, having like components that would be used to kind of accumulatively calculate those kind of things. So there's going to be a system that will govern the rules of how that works, and then the components will, you know, comprise the data of what is available. So for example, let's say that there's an item I'm thinking like items are probably going to be their own entities, and they're going to have their own like components and stuff like that. So items would have components that will say that this gives plus whatever to evasion, for example, against melee attacks or something like that. And then the system would have to look up like, okay, what items do we have equipped? Or what items are you currently affected by, or something like that. And then just sum up all the different things in a way, and then calculate the things. So that's how I'm thinking this would be. And maybe you have like a buff. Maybe some entity has like a buff that buffs evasion, maybe like an active spell or something like that, an enchantment or whatever. That also affects things, you know, things like that. That could be like a component that's, which also makes sense in a way, because in the ECS system, you can essentially only have one component of each type. So that would make sense in the terms of buffs. So you don't like stack buffs, for example. If you get buffed, it gets like overwritten. But we could do it like, maybe if you have a buff that's more powerful, maybe you don't, you know, override a better buff if you get like a buff. But anyway, I'm getting ahead of myself here. So anyway, we can have these like kind of base attributes that will kind of determine some things. And then possibly like you have like an inventory with items and stuff like that. I mean, I could just do it right now. I could just have an inventory, or maybe even just equipment. Like you have equipment on your character. So basically equipment. Well, or what would this be called? Like equip. Yeah, equipment. Equipment can, it feels like equipment can either be describing an item that is an equipment item, or it can describe like your equipment. I guess we could do like character equipment. Let's just call it equipment. All right. I'm in favor of shorter names. We could just say that, hey, yeah, this is, you know, this is your equipment. So, so here you can have like, for example, you can have like, I don't know, left hand is an optional context, because I think that having a context would make sense, because the item itself is an entity with a bunch of components on it. So it would make sense that these are entities, and that also automatically makes it so we can have anything on there, essentially. It doesn't even have to be items, I guess, but you know, it should be items, otherwise it's kind of weird. I mean, I guess technically you can hold on to you can hold on to another character. I guess you would have that character in your left hand. No, I don't know. But and then, you know, you have like, I don't know, torso, body, perhaps, head, you know, finding things like this, legs, feet. We can add whatever we want here. Rings, like fingers. Maybe we have, like Adam has 2 finger slots. And this is where you're gonna think about, okay, realism versus gameplay. How many ring equipments? Usually, like RPGs usually just allow you maybe 1 or 2. Like accessories maybe. But we can have like neck for, well, it really depends what we want to do, but we could have like, I don't know, neck for necklace, left finger for rings, right finger for rings. I don't know. All right. And then we say null. Okay. Alright, I'm gonna try something. Can you do like this? Can you say like boom boom equals null? And then if I wait, but I pressed capital A, which appends to the end. What if we do this? Okay, that works. Can we do this now? No? Okay. I was thinking like if you could like apply the same operation, like single operation, not having to apply like a macro, which is easy enough to make the macro, and it's often more powerful, of course, because you can do multiple commands. But it would also be nice if you could just make one thing, because you can repeat the last command you did with dot. And if you could like select a bunch of lines to repeat the same command. I wonder if there is something like that. Repeat last command. Yeah, here we go. No. In order to repeat same commands next, I press J dot. I mean, that's just moving the cursor down and pressing the repeat last action command. Whatever. Okay. Okay, so we have like equipment. I guess monsters would probably, maybe monsters doesn't use the same system. Maybe monsters would have like inherent, just to make things simpler maybe. Or maybe it's like race. Maybe race has like inherent abilities or stats. Yeah, we can create a component called race. And then instead of this being a struct, it can be a union enum, because components can actually be anything, really. And then it's like, could be like, I don't know, human. Oops. Human is a human race. Goblin is a goblin race. But what could differ though? I guess maybe they could have a subtype, or maybe, I'm not sure. But whatever, this is fine. So yeah, this is the two things we have right now, so. No, what the hell? And then, for example, Goblin can have, I don't know, evasion 20% or something like that. Okay. Maybe here we can say like, okay, let's calculate evasion from our base attributes. Okay, you can have things like this. So for example, it could be like, I don't know, just dexterity times evasion per dexterity. I don't know if it's gonna be diminishing returns here. Maybe, how would you do that? Like square root? Now we need decimals. So let's see, E is oh, I see. Okay, let's call it, I guess, V for evasion. Right, this is evasion per dexterity. So it's like linear here, of course. Let's set minimum of 0.1 something. And we can see that pretty quickly. Actually, maximum should be like, no, this is fine. So if we do, let's say, square root of xv, perhaps, we can see it goes like diminishing returns here. But it still pretty quickly goes up to 1, because 1 is over here. So like this you only need like 1.5 dexterity to get 100% evasion. What about v squared? I mean, we can also lower this here, I guess. I really want this to be like an asymptote towards 1 and not actually get to 1. That seems like there should be like 1 over something. Yeah. This should be an asymptote towards 1, right? But then it also should be like... So 1 means that if we 1 dexterity, we don't get anything. 2 dexterity, we get 50% evasion. 3 dexterity, we get 66% evasion. 75% evasion. Maybe instead of Okay, maybe instead of having just a flat number like percent evasion, maybe we'll have, we just get like a value that instead of getting like evasion, we would get like a defense value. I think that is how Adam does it as well. Like you get a value that is gonna be matched against the attacker's value. So would you get like defense which will mean basically evasion, but defense value. This is kind of like how hard is it to hit in melee. I guess it kind of like how it's thought of. Maybe it's like it's representing how good the armor is in a sense as well, because so the attack basically did nothing. So you have to have a high, like, I guess, precision to get through. But that doesn't make sense in a way either, because let's say you have a really powerful weapon, but you're bad at like landing a hit. Or let's say you have a really like no, the other way around. Let's say you have a really like bad weapon, like a blunt knife or something, but you're really, really good at hitting with it. So would you be able to do damage? Now there should probably be like defense value that says that, okay, how hard is it to hit? Maybe we should call it evasion value, because it's really about how good is this monster, or how good is this character entity at evading an attack, avoiding an attack. And then there could be a different value for like reducing damage, like absorbing damage. So like we would have like evasion value. How hard is it to hit in melee? I think range is kind of different. I feel like ranged attacks, you can't really evade in the same way. Unless the ranged attack is slow. Maybe it depends on the speed of the ranged attack. So some ranged attack you can't actually evade. It's just up to the attacker being able to hit. And then other attacks might be like, okay, it's a really slow ranged attack. So it kind of relies on the fact that maybe the target is like preoccupied with something else, or maybe a slow target, or stunned or something like that. So you would be able to do like a high damage, slow ranged attack. Something like that. Let's say evasion value is dexterity plus, let's call this evasion value per dexterity. I guess. I'll just put 1 there for now. Good morning, Ladieu, Loki. What's up? What's up? All right. We're working a little bit with the RPG rules here. How's your morning going? Or I should say. I guess you're the only one here right now, I think. I'm doing it by myself. Let's see. Right, how hard is it to hit in melee? And then we can have absorb value is like how much damage is required to, or how much damage is absorbed by defense. Yeah. Okay. I'm not sure what we should, I guess endurance maybe. Okay. All right. We can also have like strength gives you more damage in melee. So melee damage bonus. Kind of self-explanatory. Strength plus melee damage per strength. Now damage, I believe, is it's U size, which I think I like. I like having damage be like U size, like an integer, I mean. And then melee damage per strength. Now this could be more like a table. I like when, you know, you have, let's say, you know, you have like a table, like, okay, if you have 3 strength, okay, you get +1. And then next one maybe comes at 6 strength, or every 3 strength or something like that. But it should really be like a U size. And then this is like this times something, which could potentially be like a float, for example. So then we would actually convert you to a float first. Then convert this back. And then we will, I think we'll floor it. Yeah. And then we need to kind of do the same thing here, except here we just do, you know what? No. Let's do the same thing here. I think absorb value, these should probably also be U size, because then it's kind of like, instead of like, I guess, gradually getting things, it feels more like you get like, now you get a step up. I feel that that's more powerful in a way for feeling that you actually progress, you know? So int from float. Let's just copy that. Okay, this is such a common thing. Maybe we'll just have like a helper for this, like let's just call this like I don't know, multiply attribute and factor, and this gives us a U size. And then we'll return this UR attribute. Hello Penguin, what's up? How's it going? attribute multiply strength and melee damage per strength. Whoops. And endurance, soar value per endurance, and dexterity evasion value per dexterity. Now this could change, you know, it's not like final here, of course, and nothing is, yeah. And then let's see, so now melee damage per strength. So let's say we want like every 3 strength gives like 1 melee damage bonus or something like that. Then this would be, I guess this would be like 1/3. Essentially. Now, of course, that is not, that will probably be inaccurate at a certain point. So what I'm gonna do is I'm gonna make a little test program here. And we'll say same thing, really. I'm just gonna copy this. And we'll get like base attributes. I guess they all start at, let's say that 1. Everything starts at 1. And then we'll, so we want to log out, okay, what is melee damage bonus? And we want to make a loop, let's say 10 values, or 20 maybe. 1 to 21. Let's make this mutable. Let's set strength equals to I. Of course it's a usize, so it matches the type. And then we'll just loop through that. So of course I need to say something strength. Oops. Okay, so here we can see that for 1 and 2 it gives you 0, 3 and 4 gives you 1, 5 gives you 1 as well. So it's yeah, so 3 gives you 1, 6 gives you 2, 9, 12, 15. Okay, it actually matches up pretty well. Hello, Nightblaze the Wizard. What's up? Welcome. How's it going? Okay, so that actually works. Cool. Okay, and then we can have, you know, we can have the same thing for ranged, I guess. Range damage per maybe dexterity. And maybe this will be lower since, you know, range damage is perhaps more, you know, valuable. Range damage. Alright. Cool. And this can also have, you know, 1/2, for example. I don't know. Alright. And let's add 1. Or set that to 1 there. I guess we'll have also like a melee hit bonus. That is like, you know, how much to hit something. And that will be dexterity. Melee hit per dexterity. Maybe strength also matches in there. Maybe we'll add like dexterity plus strength or something. Dexterity plus strength. It could also be... Let's do like strength. From strength is how much do we get from strength? So melee hit per strength. And then from dexterity. And then we'll return these added like this. Now what's nice sometimes if you see like, you're looking at your stats, right? And then you're seeing like, okay, how much, like I have 10 strength. What does that give me? That's also very important, I think, because it gives you an idea of what this, not just the sum of everything, but also like what does each attribute actually give me here. Nice to see someone who actually writes their own code instead of vibe coding. Good coding, yeah, thanks. Yeah, it's I mean it's fun. So when I am I'm paralyzing vibe coding here in the background, but you know, my main focus is just programming. It's you know, it's my hobby. And now we're trying to make games as well. Are you a coder as well, Nightblaze? I'm guessing you like RPGs because of your name. Alright, we don't have to make this perfect right now. I'll just do it like this. Well, like melee hit first, strength per dexterity. Oh, iOS dev, also interesting in game dev. Okay, cool, cool, cool. So this, for example, dexterity can be better at giving you hits. So let's do like half. While strength is also good. Perhaps something like 2.5 or something. I don't know. It can all be balanced. Okay. And then we have like, so this, I think that's pretty much, I mean, we could have things like carrying capacity, stuff like that. I'm not sure if I want to think about that right now. That could be something maybe added later, perhaps. I don't know. But yeah, carrying capacity, also hit points bonus, I guess. Also, dexterity might affect things like dexterity and strength might affect things like speed as well, like movement speed, attack speed, because that also plays a crucial role here, since you know, it determines when you get your attack in. Okay, I guess we don't have to lay out everything right now. In terms of, but I'll write this down. To do move action speed bonus. Also, you know, magic stuff. We don't really have that right now, so I'll focus mostly on like this normal physical combat stuff right now. All right, so we have a little bit of stuff here. I guess that is kind of enough for us to be able to kind of test this out a little bit. So let's go over to demo and create player. So let's add base attributes there. And here we can kind of determine, you know, what our base attributes should be. We can set whatever we want. What else did we add? Equipment. That's right. So equipment. Yeah, let's do init. Equipment. Everything is empty. What else did we do? Race. That's right. So for race, we have like, for example, human. Wait, what's happening? Race. Oh, god damn it. I spelled it wrong. All right. As I made the C# there, but I'm not familiar with the syntax, but I kind of like it. Yeah, it takes a little bit getting used to. But this is really nice. Because this is like... It's like we're calling a function from the type that is expected here. Which in Zig is called a result location type. So basically we're setting equipment field right here. And this is, the type here is an equipment. As an optional equipment, but it is an equipment. And so when we type .init, we're actually calling a function that is defined on this type, the equipment type, and which returns an equipment. So this is like, I'm not sure if it's officially called like a constructor, but I would say this is kind of like a constructor function, because you call it, it's defined on the type and it gives you the type itself. So that would be like a constructor, you could say. And so if you're gonna assign something to a type, or you put it into a function argument or something, and you know what the type is, if you just say .init, you know, you get the constructors available on that type, which is really cool, because then you don't have to say, you know, equipment. You don't have to import the equipment type. You know, there's a whole bunch of stuff you don't have to do, which is really, really nice. I really enjoy that. That is like one of the super duper features of Zig, I would say. What's your main dev stack? As I understood, game dev is just a hobby, sort of mistakes, English not native. No, that's fine. I understand you perfectly. My main dev stack is, well, usually it's like TypeScript. If it's backend, it's usually C#. So I'm usually like a web dev in my like main profession. But I do want to get more into game dev and perhaps even, you know, go over full time onto game dev. So that is like a dream essentially. But yeah, I guess, you know, mostly TypeScript, I guess, because I mostly work on front end, but I do work full stack as well. But yeah. All right, so now we have these like components on the player. I want to add the components on the goblins as well. So you know what I'll do is I will add like goblin common stuff, and we will get the entity context and this is a goblin. All right. So basically, goblin common. What's different here? It's like the sprite or animation is game animations, animation key. We have position. So that gives us essentially, I think all of this is essentially common here. The only thing really different is here, animation key and perhaps health, but also the initial state. Which is a function. Well, it's a state machine. It's a state function, yes. Board position. All right, let's call this board position. Actually, we have game. So return initial. When you show equipment struct, it was declared like pub const equipment, something like that. What does const mean in this context? Const means it's not, you can't reassign. Well, it means, actually it means a couple of things. Well, for one, well, okay. So what could be confusing here for people who are not used to this type of like syntax is that this is a type definition, but it kind of looks like a variable. And the reason for why it looks like a variable, definition is because that in zig you can actually kind of, there's a comp time. There's something called comp time where you can for example, this is happening in while compiling. So basically, you can say, let's say you have a okay, what example am I gonna show? I don't know. You can do things in comp time. You can have like a thing called 5, and then you log out that, and that will give you that. So basically, it's you can actually you can kind of execute code while compiling. Essentially, is the thing. So it's part of the reason why. So this is like this, because that's part of the reason why this is like this. Because you can essentially, types are simply variables essentially, but they are like evaluated in comp time. So you can have a type that is a U32, for example. This is like a type alias here. It doesn't have to be in comp time either. This is also kind of comp time down here. It's like comp time, just make sure that it's comp time here. But it's essentially just saying this is a type alias saying t equals U32, for example. You can also, like in comp time, you can have like mutables. So like t is, well, let's say you want to compute a type, and then you say like t is that. And then you can actually, okay, this is kind of also introducing a little bit more, okay, it's already comp time, so we don't have to do things like that. But basically like this, you create a mutable type. So now it's a mutable type. And then you say like if true, whatever, whatever you want to do here. If true, then maybe t is now an F32. And then like the result of this block is essentially what this is like. You can have a label here at a block, and if you say break and then label t, the result of this entire block is gonna be this t here. So that's a way to do that. It's essentially like a function without parameters, almost, you can say. Or it's like a scope. A block of code that also results in some kind of value that we break out. And then t will be that type, So you can do some stuff with like comp time. You can like inspect types. You can construct new types from other types, and so on. So there's a whole bunch of stuff you can do with comp time. But yeah, essentially, this just means that it's a type called equipment that is a struct type. And then you can say like, for example, if you want to do an enum, you do it like this. So this is an enum definition. So it kind of follows the same pattern, regardless of what kind of type or what kind of thing it is. It's like everything is like const something equals. And then on this side, it can either be a type, it can be a variable, it can be some comp time expression, whatever. So I actually like that a lot. The only thing that doesn't work like that, I guess, are like functions. Because the functions, you have to say fn, that is now a function, so that you don't say const something equals a function. So functions are different. Also fields are defined like this. But that's it. That's basically all the kind of, maybe like what you would say, like declarations that you would basically have, essentially. And I guess arguments would be a different kind of, as well, declaration maybe. Can we write pub equipment? No, you have to have, well, you have to have const. So all variables have to be const or like const or var. So everything needs to be a const or a var when it comes to variables or unless it's a function, in which case it's just a function, which are like constant anyway. So yeah. And then another thing about constants is like, if let's say you have a constant, now of course constant x here means you can't actually change x. And then this means just a mutable number here. But if you, let's say you have an equipment and it's a constant, well, you can't also now change things inside. Like you cannot reassign it, and you cannot like change the things inside either, because everything is constant. Right. Got it. Like in many modern languages, val, var, let var, etc. Right. Exactly. But there's one extra thing here. It's like if this thing has a pointer to a mutable, then you can change that mutable. So this is a pointer to a mutable. Now that you can change, even though EQ itself is const, you can't actually change like this. But if it contains a mutable pointer, you can change that. Same in Swift. Okay, cool. then you're familiar. Get out of here. I've never actually done Swift. Do you even exist? No, you don't. So why is this? Okay, let me restart. Where does this come from? Oh, it comes from here. Okay. Oops. Here. Okay, and you do not exist anymore. Okay. Cool. Okay, animation key needs to be comp time. All right, so what's different here is essentially just the state. This would be the archer, goblin archer, and goblin archer. And this is goblin mage. All right. So now all the goblins should have base attributes, equipment, and race. I'm not sure about equipment. Let's remove equipment. Base attributes and the goblin race. And I'm not sure about this. Evasion, I would call it maybe evasion value instead. Yeah. Let's call this, actually this should have a function. Evasion value. Actually, one of these has to have some type of thing. I'm gonna say evasion value, because otherwise it will be a zero size struct, which is not like allowed in the ECS. So Evasion value should be a usize. Let's start with 1 and return evasion. Okay. So what we can do is implement like an interface where we say that, okay, if we're looking at something, if it has the function evasion value, we'll call it and then add it to our pool of evasion values. And then we'll sum all that stuff. Hello, Legendary Cerberus, what's up? So how does this work? Are you using a game engine or just straight up code? I've never heard of zig+raylib before. Yeah, it's just code, essentially. Raylib is a code library to help with a lot of stuff, with game stuff. It will help you like render textures and like primitives like rectangles, circles, lines, stuff like that. It works with 3D as well, and it also has like support for shaders, sound, music, like basically the whole package. You can create a game with it, and it's really simple to use. So its selling point is that it's like very easy to use, and it gets you started very quickly. I would say it's like a very thin setup layer, and yeah, it works really well. And then Zig is the programming language that I'm using, which is a low-level programming language with manual memory management and very close, like interfacing with C and C++ potentially as well. And so essentially, you know, with raylib, I just call like, where is this here? This is essentially what you do with raylib. You initialize a window. So now that creates the window. I can set the position because I'm streaming, so it's like at a set position. You can set the target FPS if you want to like lock the FPS to some FPS. Init audio device. You can change the volume. Yeah, that's basically it. All you need to kind of launch the game essentially, and then what you have is the loop, which, oh wait, this doesn't show the whole thing. Well, essentially how I do it is I have a logic update first, and then we have the draw, which calls raylib. Well, this is, you know, it's a little bit set up differently, but this is usually how you do it. You say like begin drawing, end drawing. If you don't have these functions called, then the program will kind of like it will like not respond. Essentially, you have to call these, and then essentially you can draw stuff between those. But that's all. That's it. That's basically all you have to do in order to get like a blank slate going. Okay, do we have any issues right now? I can show you here how it works, or the game a little bit. So this is the game right now. It kind of likes, I mean, it's very early, of course, but it's like a, I'm planning for it to be maybe like a roguelike, but with like animations and a little tiny bit of graphic stuff. So so you can make your move. It's turn-based roguelike. Yeah, like, you know, I'm not sure if you're familiar, but like the original roguelikes where, you know, you do one move and essentially like a board game. You do a move and then enemies get to do a move and so on. And then they will attack you. You go to them, attack them here. Now these mages don't do anything right now, but yeah, I'm essentially just adding piece by piece here. It's the first time actually trying to do something like a roguelike. But yeah, it's pretty cool so far to make this game. And yeah. So right now I'm working on like the kind of more like the rules of the game, like how like when you attack something, can it evade your attack, or can it, you know, do a counter attack or something like that, you know. I'm doing the like the basics now. So you have like base attributes, you can calculate how much you know, accuracy you have versus how much they can evade and stuff like that. So I have to kind of think about, okay, how should this work? But now the goblins and the player have base attributes and a race, which might give also like things there. I guess the race. Well, let's do it like this. So now I need like the melee attack action needs to determine the melee attack always hits, but now we need to determine should we hit or should we miss. So basically we have like the target and we have the component that is attacking. So I guess we'll do like if hit I don't know what to call this. Successful attack. If evade, if I don't know, let's just say hits or lands attack. If we land the attack, let's pass in, well, we don't need to. If we land the attack, we will then deal the damage. Alright, Penguin. If we land the attack, we deal the damage. Otherwise, we don't deal the damage. And if we don't deal the damage, I think we need to also store some stuff on here, because we need to kind of change the animation based on that, I think. So we could have like damage dealt. We can have, because that's the actual damage. So maybe it like absorb damage. So we have to have a new thing there. What else? Yeah, if we landed the attack, of course. I mean, I guess landed attack should be equal to lands attack. But there's kind of two things here. It's like we have to actually do the board update, and then we also have to create an animation based on what happened. So if we landed the attack, we will do the board update, and then the damage dealt is gonna be, well, I guess we'll also have a function for that. Damage dealt damage dealt. Yes, and we can also calculate if we cost the death right now. Wait. Oh, I guess we have to fetch that there. Let's do that. All right, and then over at the animation, we will say, I guess here, like if we actually dealt damage, if this is more than 0, then we do the damage. Lance attack. Let's just return true for now. And then damage dealt. I'll just return damage for now. Dealt. Oh. Okay. So now it's like, we only show the damage number if we actually dealt damage. I guess if we didn't deal damage, maybe there's like a different animation. I don't know. If they evade, maybe we'll show an evasion. Yeah. So basically, if landed attack is false, if we didn't land the attack, we want to show like the evade evasion, or evade evasion. We want to show the evade animation. Let's see. So basically here it's like, then we do this, right? So this is the evasion. If we didn't land the attack, we will do an evasion animation where the thing is the target does the evasion animation. And how is the evasion animation gonna look? Well, let's do like evasion speed is gonna be something, I don't know. Let's do like 3. That's like 3 pixels per frame, I think, or something. Maybe. Okay. Well, we'll see how it looks. And then what? So, and then like what direction is it gonna move? So the thing is like a melee attack always, it's like the melee attack activation is like half rel. It goes into the target and then back, right? So it's like, here's the attacker, here's the enemy. So they go into there and back. Now, if the evasion happens, might want to go like some kind of orthogonal way at random or something. So we can say, let's say like evasion is going to be half rel, and then we rotate it by some angle, and the angle is going to be either 50% chance to be 90 degrees, which is pi over 2, or let's do pi over either 2 or -2. Right? What the hell? Is it because this is content? This doesn't make sense to me. Evasion or divisor. Feels like this is the same thing, right? Value with comp time, all the comp time flow depends on runtime control flow. What? What if we set it to F32? Okay, now it works. So, okay, that's kind of a weird thing with Zig. Sometimes the comp time stuff kind of spills over. It's like, this is comp time, float. And if you divide it, it kind of, I guess, if you don't put any type in here, it like expects this to be a comp time float here. But I didn't want it to be a comp time float. I wanted it to be an F32. But it was complaining because it was saying like, well, this should become a comp time float because that's what I'm kind of infer it to be. But you have some runtime stuff here that like can't be run in comp time. So then it's a compile error. So you have to kind of say that, well, this is not a comp time float, it's a F32. What we also could have done is like say as F32 and then this also works. So that kind of like sort of cast, it's not really a cast, but well, sometimes it's a cast, but it's essentially, it's changing what type we expect this expression to be. So we're saying this expression should be an F32 and not a comp time float. And now all of a sudden it works because that's how it is. But anyway, so we calculate the thing based on chance. This basically now is like pre-calculated every time something attacks. That is the evasion sort of direction. And so that is good. Now what I also want to do is probably just also scale it by 2 actually, because so let's do like rel, because I think maybe that looks better. I don't know. We'll see. Let's see. This is rel. So instead of using half rel, we'll just use rel. So this would be evasion rel. So what this will do is like if we didn't land the attack, whenever the attack starts, or whenever the attack kind of, when you try to land the attack, the enemy will like do the evasion animation here, which is a sequence, and first it moves like, you know, in the evasion direction, but then it moves back again. So there we go. So now let's say we go to melee attack. Let's say we always, like, let's say this is just false every time. So we can test this here. So now all melee attacks should like miss essentially. Maybe it's a little bit fast. It does work, and I don't do any damage. So maybe maybe it's too fast, the evasion speed. Let's try 1. Okay, maybe this maybe it's good, but let's increase maybe the speed. Let's go back to half row actually. Okay, now it might be too fast again. Let's go back to 1. Yeah, I think that's good. You see, it kind of chooses like a random direction there. Cool. So now we basically have, you know, evasion for melee attacks and little animation there. Works for all entities. And yeah, now we just basically need to figure out when do we actually land an attack and when we don't land an attack. And this is probably going to change a whole lot. But let's start with grabbing some stuff. So let's calculate. So essentially, okay, let's say we get an evasion value. Or, yeah, evasion value should be equal to calculate evasion value from the target. And then we have the hit value, which is going to be calculate hit value from this. And then somehow we're going to pit these against each other. So let's say the diff is hit value minus evasion value. Now these are like U size, so we actually need to kind of make this an I32. Maybe we should make them I32s actually, so they can be negative. That actually makes sense. Well, maybe the result of these functions are I32s actually. Yeah. I'll just return 0 for now and hit value. Okay, so we have the evasion value, the hit value. We need the diff is hit value minus evasion value. Now, how do we determine how do we calculate this? I'm pushing the goalpost here, but I'm also organizing a little bit. So I'm doing a little bit of top-down programming here. How do we calculate from diff? Well, it's going to be like a balance issue, really. So maybe we'll bring out decimals here again. Okay, so we kind of have this graph here where wait, how do we face this? I think it's like x -1, no, +1. There we go. So this kind of says that if you have 0 value, there's, I guess, or 0, I guess 0 difference maybe. There's like a 0% chance to miss, I guess. We would do like 1 over, yeah, 1 or 1 minus, you know. Maybe for this one, we would do something like this. So if you have 0, like, I guess, yeah, we have to start at some point. You have 0. there's like 100% chance to hit. If the diff is 1, there's a 50% chance to hit, and so on and so forth. Maybe that's too strong of evasion. So we can change this value here to make it like something more like this. Or that seems to do things in a different way. Maybe we'll square this. Did that actually do anything? Yes, it does. We square it, and now it's still kind of steep. Oh, I see. Wait, what if we do this? +5. Hello, Bullicha. What's up? Welcome. How is the game dev? It's going good. Doing a little bit of I don't know. I'm trying to find an algorithm to work out if an attack is gonna land or not. This kind of just looks like a linear thing. Maybe that's what I want. I don't know. I'm like making this weird thing, and it just looks like a linear. So basically, even if like you start at the base kind of value here, you can miss. You have a tiny chance to miss anyway. And if the difference is 1, now they have like 87, 81. Yeah, I guess it's fine. It will never reach 0, so you'll never actually get like 100% chance to evade. And you will, the more you get, the smaller actually upgrade you will get here. So I guess this should be good, perhaps, as a initial here. What if I copy this? Will this actually copy to? Okay. So we have the diff. And now we just need to plug this in here. So we have square root. We have 1 over this. Left, right. Oh, this is just a parenthesis, I guess. And x is going to be diff. And then v, and then this would be like times power. Is there like at pow? No. Okay, z is, I think it was 3. V, no. Wait. No, yeah, v is the factor. If v is just a, so this is just a constant here. Factor is this part. And then I guess this would be x. Something like this. I mean, it's not really x, it's more like, I don't know, value or something. I don't know. Okay. 3 arguments, right? You want a type. Let's, I guess, F32. Value is, so diff is now I32. And actually, you know what? Let's make this into a float. Let's make this into an I or an F32 instead. So this is now an F32, this is an F32, and so on. Okay, cool. Whoops, you didn't see any of that. Okay, well, anyway, I did this one in code here. Excuse me. So we calculate the diff. It's an F32. It's hit value minus evasion value. We have the factor, which is like the v to the power of z, which v was 0.6, z was 3. And we take the diff plus 5 and times with the factor. Then we take 1 over that, and we square root it, and that's the final chance. However, it's kind of like saying that, well, if evasion and hit value are the same, we get like a value of 0, so a diff of 0, which on the function here is kind of like the best case scenario almost. I'm gonna say that we cap it at 0 because, yeah, there should always be a chance to miss, you know. But let's say we cap it at 0. That means that 0 is kind of like the base kind of value. So what we need to do is we need to shift it over a little bit. So x plus 5, let's do like x plus 5, like we can do maybe, it depends on kind of how, so this is like where this absolute value comes in. Let's do like a, and let's start at 5. and we'll end at, I don't know, 25 or something. So this kind of determines, okay, what value, like how much of a negative would you need to have in order to like sort of guarantee a hit as well. However, this also kind of changes how the rest of this goes down here as well. So actually, this kind of makes it so that if you have 0, now it's like 76% chance to hit. Which is a hefty amount, I guess, chance to miss as well. And then you just need a little bit to increase, I guess, to 50%. You would need like, well, actually, it's kind of a lot. You would need like a difference of 10. Whatever. Let's start with this. We can kind of modify it however we want to go there. So A is, so let's change A to 8 here. I mean, we could actually match these here. Let's say A is 8, V was 0.6, Z was 3. There we go. And then we can tune this and find out a better thing later. Okay. Cool, so that's the chance to hit. Now all we need to do is like actually just calculate these. And it's just gonna be like, you know, a sum of all the different sources that could have evasion value, for example, or hit value. So we'll start with, let's do a sum of I32 is 0. And we'll return the sum. And so for now, all we have like base attributes. We have equipment. I guess we would try to get it as well. So basically, if we have base attributes, because maybe you try to hit some inanimate object that doesn't have base attributes or something, maybe. So base attributes would be base attributes, and we'll just say sum plus equals base attributes dot evasion value. Okay, and then we'll basically do the same thing for everything else. So we'll have like race. If we have a race, the race itself does not have evasion value, but we can switch on the race. We can do inline else. And we get the race here, and we can say if has declaration, or if has func or method type of R evasion value, then that's what it's going to be. So r.evasion value can we format it like that? Not sure. I guess we can do it like that. And this is a U size, this is an I32, so we actually have to like int cast this here. Same thing here, let's int cast just in case. Oh, let's do constant. Let's just make these constants instead. Don't need to change them anyway. I32 find void. Right, so if we don't have the evasion value, I guess it's just 0. And then I guess there's equipment as well. Which should probably have evasion value function. And I'll just return 0 for now. Because this would probably, well, actually, you know what? We can do some comp time stuff here. So basically, we can inline for the fields of this. We get a field, and we can check like if. No, this no actually. Yeah. So if add field self field name, we get the item. So this is now the equipped item that we get. Because this is these are all optionals. So if we do an if and then capture, we'll check if it's populated. If it's populated, we get the item here. And then we simply, well, it's kind of, we don't have a component for this for items, but I guess we'll add like a to do, add like, you know, calculate item evasion value somehow through like item components, which they could have like, you know, an evasion value, simply an evasion value component that is given to the item or something like that as an effect or something like that. And then here as well, we'll start with a sum, and we'll return this sum here. I mean, it would kind of make sense if we do this with I32, because maybe you have a cursed item that makes it easier to hit you, so we get like a negative evasion value. So maybe it should be I32 instead. Hello, Svedara, what's up? Well, long time no see, is how you say it. Your schools are open, so I won't be able to watch live streams like before. Sorry, anyways. How's the progress going? Oh, okay. Well, you should focus on school. That's way more important, so that's good. But yeah, the progress, yeah, it's going good. Well, I'm doing like some RPG rules things right now. And try to figure out how to kind of make it with like ECS, and you know, it's like a board game, RPG. Then I'm kind of trying to implement using ECS. So it's kind of interesting because I've never really done this sort of thing before here. So evasion value, that looks at all the things that has things. We don't really have any way to check those things, but this will generically go through all the items, and it's never mutated. Now it's mutated, okay. It goes through all the items, and it will calculate the evasion value for each item, add this value up, and now we have the total thing. Cool. And so cast. Awesome. So we have this three things now that I've implemented sort of here: base attributes, race, and equipment. Cool. The only thing that kind of gives you is like base attributes and race. The goblins have like an inherent evasion bonus, while base attributes is based on like dexterity. So, cool. Now, the hit value, I mean, that's kind of the same thing. We just go through all of these. I might like generalize this later. I mean, I'll probably guarantee you I will. So let's create the sum here again. All right, and then instead of evasion value, it's going to be hit value. Actually, it's like melee hit value. and that you don't have this function. I mean, it's called bonus. Should it be called bonus or value to kind of match the other one? Bonus sounds more fun, but let's call it value right now. Okay. And these would be melee hit value. And you don't have that. Let's put this here. Cool. Okay. I do want to log stuff out, so let's do like someone hits. I'm not sure. Let's do like we know what race they are. So let's get the race. Hits or attacks. So we show like human attacks goblin, right? And then we can show hit value, evasion value. So hit value is hit value, evasion value is evasion value. And then of course we have the diff. And then we have the chance. Okay. So now we should have that be active. And we'll see how that works. So here we can see human attacks goblin. Hit value is 0, evasion value is 1, miss or diff is -1. So chance will be 81% chance. And I didn't see if we actually did the, and there we go, we missed. There we hit, we missed, and we hit. So now we have basic, like, we have like evasion here. Cool. Okay. I see. It's like hitting me for, well, there's 76% chance. Diff is 0. Wait, hang on. Oh, it's like the other way around. Hang on. Did I forget to do like 1 minus or something? No. No, that's true. That's true. -1. It was -1, so it's easier to hit. 0 is harder to hit. Yes. It's correct. Okay. Cool. All right. So we have that now. Kind of like a basis for that. How can we, do I wanna like generalize this now, or how do I wanna do this? Because I'm thinking like putting all these in, like, let's say race actually just implements evasion value, for example. Here, like evasion value, and then return, switch, inline else, whoops, inline else, race, and if has method type of race, evasion value. Actually, we can go on further. We can say function name. Then we will call it. We will do race evasion value, else 0. So there we go. Now we have evasion value on that. We can also do hit, melee hit value as well. Actually, we can even do this. Can this be fully generic? So basically, yeah, because we can just do field type of R. The field is source function name, or it's just the function name. Oops. Oh, it doesn't work for built-ins, right? And we call it. So now it's like fully generic here. We'll say like call implementation self and then function name. And I guess it helps if it's a comp time string. And this gives us, oh, but what does it give us? This is the conundrum here. We could, I mean, we can actually have the type, the return type part of this, I guess. But this would essentially just be this, right? And then here is like return self call implementation, return type, function name. This can also be generalized. It can be like return type. Return type T is type info type of no type info this no field this source function name. This gives us the function. We take a type info of that. That should be a function. And we take the return type or else void. Right, so now we have the return type of this function. This is like a generic line of code that can be used anywhere, essentially in any function body to get the return type of this function. I guess it has to be on a struct, but technically all functions are part of a struct. Okay, and then this would be T. So these two lines of code are now generic for all functions anywhere, any function in any struct. Well, I guess, you know, it has to be, together with this would have to be you know, a union enum, then that's the whole thing. That's the whole point. So basically, it's like generic code to call the union enum implementation of the same function that you call here, essentially. So we don't have to repeat that godforsaken code every time. Because now if I want to have a new implementation, I can implement it here. If it's an entirely new function, I just have to copy this and then change the name and the return type, and that's it. Okay. So if we go back now to melee attack, now instead of doing switch here, we can just call raise evasion value instead. So now this is, you know, you can see the pattern here. So instead of doing this pattern, what we'll do is we'll make a components list, which is going to be, you know, base attributes, race, and equipment. And we're going to do an inline for components. We'll get a component type out. And we'll say if we get this component type, we will, let's do like this. If we get the component type out, we get the component, and we will say sum plus equal int cast component evasion value. So now anytime we implement a new component that has this interface, we can just add it to this list. Good. I mean, technically, another way we can even generalize this, because all components are added to game.c. So technically, we can just iterate through all components. We can go through all the fields of game.c. We can get the field that should now be a type. And we will say if the field type has a method, no, the field type is a type. Hang on. Yes, it's it's actually a declaration, actually. Or is it? The field of a type. I think we get the declarations. Or should we go for declarations instead? Declarations. Yeah, we get a declaration. And so the component type would be game, so that would be field game.c declaration name. That is the component type. And then if the component type has a method called evasion value, then we try to get it and do the thing. So now we don't even need to specify what components we're looking for. We just look for all components that have the method evasion value. And then we inject this code, essentially. This is kind of like a code generation. Depending on which components has evasion value, we add an if statement here. So that says, okay, try to get this component and then add the evasion value. So now it's like, if this is fully generic here. Declarations in the comp time. Are you kidding me right now? Okay, let's mark this as comp time. There we go. Okay, now we get some issue here with type, found, function, blah, blah, blah. Field. Oh, let's do like type of. And you, right, so this, we need to call, well, we need to actually put that in there, yes, there we go. Okay, now we have to do the same thing here, type of, and that. We're kind of doing, all right, Penguin. A lot of generic stuff here. I like generic stuff. I mean, it's good, you know, it's very good sometimes, but it also kind of forces you into this kind of pattern or architecture as well. So it's like good and bad at the same time. So I think the most bad is when you've been away from a system you just made, and then you get back, and now it's like, whoa, how did this work again? And you have to kind of like remember everything. Oh, it works like this. Oh yeah, I just have to do this. Oh yeah, that's it. So I guess whenever you do something like this, maybe it's a good idea to kind of document a little bit on how to do things. I mean, sometimes you can just look at how it works, and sometimes you can just go in and, oh, it works like this. Okay, you can quickly get it. But sometimes that's not the case. So sometimes it's actually good to, I usually never like document stuff, but usually sometimes when it's like, you know that this is going to get convoluted, whenever you kind of imagine yourself going away for a while and then come back, now you're going to be like, what the hell is happening here? How does this work? You know, because you're not going to remember. That's the thing, because you've been working on other stuff that now occupies your brain. That's going to probably work entirely differently, probably. And now you have to remember how to do things here. So yeah. But yeah, look at this. I think we can go even one step further here. So this would be for, you know, can you see the pattern here? Melee attack value. We call melee attack value. What's the difference from this to this? It's the name of the function, right? So instead of calling this directly, we would say let's say we have a function name. We have a function name that is, well, for now it's mainly hit value, let's say. And it has to be comp time known. What can we do here? It's a function name. What we do is we say field of component function name, and we have to call that with the component, and there we go. So that should be the same thing. And then over here we have the same code, but the name is evasion value. Okay, first of all, let's just run this to see if it compiles and works and everything. See if we get the same values and everything like that. Yeah, it's still, you know, you can see it still works. So we can also generalize this, like generalize to get this value out from all different components. Like get some value out, get like value, and I guess for this one it's probably good to have like a t. Well, the thing is, like, it's a sum, so what do we want to do with the sum? Maybe we actually get an iterator and then determine what to do with that, perhaps. I'm not sure. Also, it kind of, yeah, I don't know. Yeah. Because either you can get the sum or you can get the factor. You can even like, yeah, we can even generalize the operation that we're doing here. I mean, either we could do that like an iterator where you can fully determine what to do, or you can also just, you can also say, like, put an enum in that kind of determines the operation you want to do. So like operation is value operation or something. And this is an enum, so either we do the sum or the product or something like that. And this will give us t. And we also need the function name. Which has to be comp time. Okay, and then here we'll switch on operation if the operation is the sum. Value t. Now it has to be a number, so we can safely say it's going to be 0. Because it doesn't make sense otherwise. Okay, if it's a sum, the value is plus equal to the next value. This is going to be like, I'm going to call this next here. Next, if it's a product, then value times equal to next. Actually, if it's a product, yeah, we'll have to switch on the operation as well here. This is like the identity value. We have to start with, if it's a sum, we start with 0. If it's a product, we have to start with 1. Otherwise, you know, it's gonna, everything's gonna be 0, right? Okay. And then intcast is like, okay, well, let's not do intcast. Now we have to kind of make sure that it should be like, everything should be the same. We could intcast of the result of get type, or get value, I mean. So now it's like, we can just return get value, usize, operation is sum, the function name is evasion value, and the context is context, and then we intcast here instead. And there we go. Now we've generalized that as well. All right. Melee hit value. All right. Kind of gone crazy on this. It's a little bit premature, I would say. I'm calling it now. It's a little bit premature to do this, but I think since it's like a system of numbers, and potentially you will try to gather all the stats and then have algorithms based on those stats. That's how I see it. So this function is like for gathering all the stats for the character, and then we're going to use those stats in an algorithm to kind of determine real outcomes. For example, here is evasion value, hit value, and then we have an algorithm to calculate the chance to hit, right? So that makes sense, right? I mean, it is a little bit premature how we do this, but I think this is a good plan here. It's an educated guess, I guess. Hey, Zebid Naga, what's up? Hey, are you using Linux? Yes. And no. I'm using Windows as my host operating system. That is the operating system I have installed on my, computer. That is the operating system that I'm like logging into, when I start up the computer. But then this Linux is run in a virtual machine using a thing called WSL. I'm not sure if you're familiar with that. It's like Linux, or I mean, it's like Windows. I think the name is called Windows Subsystem for Linux, or something like that. Windows Subsystem Linux, or something like that. Which essentially they have a bunch of helper kernel stuff or something for running Linux in Windows, and it works pretty well, actually, I would say. I just use it for, like, it even works like spawning windows and stuff like that. Like, you can actually get Windows running through this Linux here, but I'm mostly using it for, the terminal based stuff to develop things. So I'm basically I'm always using Linux for development and then Windows for playing games, essentially. Or essentially everything else. Yeah. All right, so let's see. It's hard to answer a question when you don't know, you don't know what the person knows that you're answering. So it's hard to know what you should explain and what you shouldn't explain. I tend to go in a bit of detail just because it's like a habit at work. It's like, because it's so bad when there's misunderstandings at work when you're working together on like a software project and things has to be like, things has to work, So yeah, like trying to like explain something at certain degrees is like gives me a habit there to explain things maybe more than I should. I don't know. Anyway, because I've been at the other side as well, when people explain way too in detail that you think that, yeah, I already know this, so you don't need to explain this. Yeah. But then they still keep going, and it starts to get annoying because you think that, well, I know this, you don't have to explain, I don't know. Anyway. Did we test this now, or what's happening? Yeah, I think we're just back to where we were. It's just that we've generalized the whole idea of like getting a value from the thing. So it's kind of hard to tell if we missed or not when you're not looking at down there. So I'm gonna say if we landed the attack, I'm gonna say it just, no, not high, hit. Otherwise it will say miss. Miss. Hit. Great. Cool. Now let's add the damage bonus. And then essentially we can just say like damage bonus is going to be get value. I guess it's a U size. The operation is sum. The function name is melee damage bonus. And the context is context. So yeah, it's just gonna go in, look at all possible components that we have. Do you have a function called melee damage bonus? Okay, then we call that, add this to the sum, we get the value out. And then we say damage plus damage bonus. And now I think we get a damage bonus at yeah, we don't have damage bonus, so we get a damage bonus at like a, oh yeah, well this is wrong actually. This should be damage dealt. Why do I say dealt? I don't know. Okay, we still don't have any damage bonus, but if we go to our character and we up our strength a little bit, what we can do is we can say here strength equals Let's say 3. Then we should get like 1 damage bonus from that. Miss. And there we go. Now we get 2 damage. Nice. I'm also kind of noticing that it's kind of hard to tell the number here. Unless the background is dark. If my player was in the way, it kind of looked a little bit strange there. So maybe... So I'm not sure if Raylib has a way to like outline text. I know it can be done probably with a shader. Like it can be done with like a shader, I think. Raylib text outline. Oh, you just draw the same text a bunch of times. Okay. Draw damage numbers. So we need the... Well, actually, let's do like draw text outline. Text. Position. And I guess color. Position minus size. So basically position minus 1, let's say. Position X. Let's do this actually. First is like -1, -1. I guess it's just like this. And then we actually draw the text. I mean, outline can be, actually outline can just be an option into here. Let's do like an optional color. So if we're outlined, we get the outline color here. And we do like -1, -1, -1, -1. Yeah. So now we just say like X, center true, outlined, black. Negative, negative, plus, negative, negative, plus, plus, plus. Yeah, because I'm thinking like, wait, it should be +1 here, right? +1, +1. There we go. I mean, it works for sufficiently small outlines. Yeah, it works. Cool. Except it doesn't work fully. There's like one tiny... Yeah. It's like the left one does not work. Well, these are integers, so it's like, it doesn't make sense. put this here. Okay, we should see a bunch of numbers. Kind of hard to tell. I guess we'll move them across a little bit more. Yeah, you can see that on the one. It doesn't show black on like the bottom or on the left. I think it's because it's like too thin. So we need to draw, I think, like 2 or 4 more or something like that. We need to draw like just without like x plus 1, x minus 1, and x and a y plus 1, y minus 1. We're gonna a whole bunch of drawing here, but yeah. There we go. Okay. The mages should have less HP. And the rangers probably. Okay. It's starting to feel like a real RPG whenever you can miss a bunch of attacks. Alright. Cool. And you know, can do things like we can increase the amount of health you have and then add a little bit of randomness. You can crit, blah 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 blah. There's a whole bunch of things we can do. But yeah, we have a lot of stuff happening here now. Really cool. What to do now? Do we have any on our to-do list here? Move, action, speed. I feel like we've been pretty productive this session here. Calculate item evasion value. That's right. Actually, you know what? We can just do the same kind of thing here, like generic thing. If we go to melee attack, we move this this thing out to a kind of util place, and these as well. Let's move these to like board. I guess stats. I'm actually gonna rename you also to evasion value. And you are melee hit value. And you know what we can do? Actually, we can make an enum. So basically, get stat. The only issue here is like, what will the return type be? We would kind of know though. You know, let's say we have an enum that is like stats. This is like the stat. You know, it's and then like stat type of stat that we want to get. Let's say this has to be comp time now. It's a comp time stat that we want to get. And with the return type depends on the stat we put in. And then you have a declaration or a function called type. And then stat is self or this. And then we'll return a type. And then we'll switch on stat. Also, this needs to be comp time. And then it's like, okay, well, let's say we have melee hit value. We have evasion value. Okay, so if we have melee hit value, that's gonna be a, I don't know, a U size, let's say. Or an evasion hit value, or evasion value, that's gonna be U size. So if we want to add a new stat, we just add it here. We will add it to the type. And I think that will be it. So then here, basically, we can also have what is kind of the function name. Now, the thing is, we could probably like construct the function name from the name of the thing here. So this would be a const u8. Now you can either just like do this. We can also do a, you know, we can actually just make a string. So we can make like kebab, or this is snake case to camel case. So let's just make a camel here. And we'll return the camel. Now this is all comp time, so I'm gonna mark this comp time so we don't get any weird stuff happening. Okay, and then we have like our tag name. It's gonna be tag name of stat. Okay, and then we'll loop through tag name of length. Okay, that's I. We're gonna check if tag I equals underscore. If it does, we're gonna skip that. I also want to have another one called J, starts at 0. So if we get an underscore, we basically want to skip past that and then have a... You know what? We can do a switch state machine. I've never done this before. Let's do a switch. This is like a label switch state machine. which starts out by looking at this. I think this works. If it's this, then we're gonna continue. Wait, how the hell did this work? Yeah, so you continue with a kind of like a payload, which kind of, right. So instead of switching on the value itself, we will switch on, yeah. So instead of switching on the value, we switch on like a state. And the state is like something that can be read, I guess, normal like state. We can have capitalize. I think that's it right now. So what the hell? So then we'll say if we're in the read state, then we will say if t of I equals underscore, we will continue the state machine with capitalize. But we also want to increase I by 1 as well. If, and we probably also need j, because I marks the index of the source, and j marks the index of the target. Actually, we don't need j because we just append to the target. That's right. Okay, so if that is underscore, we increase I by 1. We continue with capitalize, and so capitalize will say camel equals camel plus, and then item is a string with actually, I'm pretty sure we can do this here. No, maybe not. Actually, you have to do something like this in order for the compiler to be happy. So this will be like ti, but then we have to capitalize. So we have to do like ASCII to upper. Which is simply a operation like that, yes. Cool. So we have like a comp time thing that does this thing. All right, so capitalize, and then we increase I by 1, and we continue now with read. If it's not an underscore, we will simply we will simply add the item in there, but it's not going to be upper. And then I plus equals to 1, and then we'll continue with read. Another thing we want to check, like watch out for, is if we are at the end. So if t.length, well, if I is more than or equal to t.length, we will break. I guess that we can have that here as well. Okay, so now we made like, this is the first time I'm doing this. It's like a switch state machine where you start with a mutable state. Actually, it doesn't have to be mutable, I guess. We start with read. So these are the states, read or capitalize. We start with read. We will check each time, like, what state are we in? Are we in read? Okay, well then we check if we're at the end. We're at the end. We will check, do we have an underscore? In case, increase I by 1 and go to now capitalize state. And that will actually go straight to here, capitalize state. We'll check if we're at the end, then we're done. Otherwise, we will uppercase the next one, and we will append that, increase I by 1, and go back to read. And so this will just continue. And if we didn't get an underscore, then we just append the character normally, and we go back to read again. So basically, it will read until it reaches an underscore, or at the end, capitalize, go back to read, and so on and so forth until we have a camel case. Okay, so there we're doing some comp time. You know, some comp time, essentially break SM. Yeah, then we break the whole thing. So we're doing some comp time, like, you know, name, like string manipulation using a switch state machine. Okay, so then the function name is now like comp time calculated from the name here. Okay, so when we do this, we can get the function name from stat function name of stat. And that's basically all we need, because now we can just return get value, the type of stat. The operation is also determined by the stat. So operation and the function name, which I guess we can also put like this here. Function name. And then at the end, we also need a context. So there we go. Very, very cool. And perhaps we'll even put the context first, like this. Okay. So we need the operation. And this will also be like a map. We don't know each operation depending on, it depends on. So these will be sums, and this will be an operation here. And this would be the operation. And there we go. So now in order to get a stat, what we can do is we can, like, well, if we go to board and we say stats, now we can say here, we can say like game dot board stats, and we can simply get like evasion value of the context. Well, or we could just get stat context evasion value, and that would give us the evasion value. Now it even knows it's a use size, so that's actually pretty cool. If we were to change this, let's say the evasion value, let's say the melee hit is an I32, evasion value is use size. We get like hit value, game board stats, get stat, melee hit value. Now this is an I32. Okay, I see. It actually gets like, it doesn't know which it is. I see. That's too bad. I wonder if there's a way we could do it. Maybe with a table instead? Nah. It's like, it doesn't work with like computational comp time. But it's just the LSP. The compiler knows what type it is. It's just the LSP doesn't know, right? So, but yeah. I think we need to change these to I32s anyway, so let's actually do that. Oh, we actually got an issue here. Expected type. Wait. Oh. I actually have to specify that this is a slice. And I was complaining that this is a U size because our evasion values are not actually I32s. So let's change those. Let's change, everything should probably be like I32s. After multiply. I don't know. Let's change everything to I32s. Except for these ones, I guess. Yeah. But that might actually become a lot of problems though. You know what? Let's make these I32s as well. Because otherwise we have to cast here and there, we have to cast everywhere. Hello, Woofathere. What's up? What's up? Thank you for the follow. Thank you. Thank you. Hello, hello. Oh, holy crap! Followers goal 260. Thank you, everyone. Yeah, awesome. We're growing and growing. Stat. Gets that. And now melee damage bonus we don't have, so we have to implement that. Love the keystroke you're doing, keeping it up. Nice. Melee damage bonus. Alright, so melee damage bonus. And it's gonna be a sum. There we go. Except you are an I32. And I guess the damage is an I32 as well. And I guess the whole thing, everything like health component. It's like, I guess we'll put everything as I32 perhaps. Even though maybe it doesn't make sense for them to be and then this doesn't make sense anymore. There we go. Expected type, U size found, I32. Damage number. Let's do I32 for you. Strength. People still writing code, which I admire. There's a surprisingly large amount of people that complains about... Well, it's not surprising they're complaining, but there's a surprisingly large amount of people coming in here complaining about people not writing code for real. But look at this. What's this? You didn't see that. I mean, I don't know. I don't mind vibe coding. I don't think vibe coding is super interesting to watch, maybe. I mean, coding is fun. That's why I do it. Coding is like a drug. What's happening? U size, attributes, U size, no, equipment, U size, yes, you are still a U size. Okay, this was the whole thing. Coding is what we enjoy, exactly, yeah. But I feel the pressure of the time. People say AI exists, so you should do more in less time. I mean, yeah, if you're working... Hello, Nedbok. Thank you for the follow. Welcome, welcome. I would say, like... Well, yeah, if you're, like, working at a workplace, and it's kind of the norm that everyone uses AI... Hello, hello. Then it's like, I don't see any issue with using it, as long as you're using it, like, you know, in a way that doesn't, like, annoy everyone, I guess. Unless that's your goal. I don't know. That's why I really have the fear of losing my coding skills. You should always practice. I think, yeah, I think there's a real... That's the whole issue with AI as well. Or another large issue that I think maybe some people don't really think about or want to think about is, like, what if everyone starts to use AI? No one codes anymore. Like, AI gets so good that no one have to code anymore. Everyone just uses AI. And then you become, like, you know, a prompt engineer or something instead. And you basically forget how to code, or you get bad at code. And eventually, you know, the children that grows up, they don't even learn how to code. They just use AI. They just learn how to use AI to code instead of coding themselves. So in the end, you would get a bunch of people after some generations, you would get like a bunch of people that doesn't know, and no one knows the code anymore, how to code. It's just AI. And is that good or bad? It's like, well, that's the far future, I guess, potential future that we can get to. So how are we gonna do that? Because we probably need someone that knows something, right? Well, unless like every coding application would be replaced by AI. I don't know. We would kind of lose the technology on how to build the AI from the start. Like, once we have it, now we can use it to do everything. But we lost the technology to kind of build it from the start. Hello, Crashlog. Welcome. How's your day going? It's going good. Going good. It's a bit warm in here, so I'm getting a little bit of a tiredness from the heat here. But it's we're being very productive today. We're having some cool discussions here. I would not use AI to produce something I don't know myself. Yeah, it's all in, you know, I get why people feel like that. I feel like that as well. Like, especially if I, well, it depends. If I just want to make a tool, I don't really care about how it's done. I just want to use a tool that kind of works. Then it's not super important that I know every nook and cranny of the code. Especially now I'm kind of using AI to make like a language here. It's just going to be like a tool for me personally that I'm going to use to be more productive, essentially. But if I'm working at a workplace and, you know, other people rely on my code to be good, or we're working together, you know, you have a code base, you work with your colleagues, and you code review each other's code and so on and so forth, then you should, like, especially, yeah, you should pay attention to the code updates, especially now when the AI is like, it's good, but it's not, it can't replace every programmer yet. So it's like, if there's bugs shows up through some updates, then if you're not up to date with the code or how it works, it's gonna take you like way longer to actually figure out how to solve the bugs. I mean, sure, some bugs it takes long to find out and stuff like that, but I think it will, like, if you're not up to date with knowing the code, you're gonna have a tough time in, like, solving bugs and implementing new features as well. And depending on how, you know, how your communication is with the other team or with the team or other teams, then it's also like sometimes communication gets through via code. So it's like you see some updates happening and yeah. But anyway, yeah, I think you can definitely use AI, I would say. And it's yeah. If you don't like using it, I don't see any issue with not using it. I think that even if you use AI, it's like you have to know how to use it to be productive as well. It's not like you just use AI and you'll be more productive. That's not really how it works. You have to learn how to use it, when it's good to use it, because it's not good in every situation. If you want to have a good quality code base. So yeah. And it's also not like free work or, you know, either, because I think it's just your responsibility. You push up code, you need to know what you've changed. So you need to go in, like I always do, like a little code review of my own thing. When I push something up, I always go through just checking out, did I miss something obvious, and fix that before calling for help, you know, or calling for a code review. Everything is emergent, as the AI will not replace skilled human, cause new scenarios will occur, human will need to learn self-AI work these scenarios. Yeah, as it is right now, you know, AI can't do everything. So, but it can help with some stuff, but it's just, I don't know, it feels like it's so niche right now with how to use it. So it's like it takes a lot of focus to use it as well. So it's like you can get into the trap of thinking that it's going to help me be super, like 10 times more productive. That's probably not the case. And as you said, you also get like rusty and stuff. You kind of forget about how to think about the project. Maybe you don't even want to think about the project in the end. Maybe you just like want to delegate everything to AI. It's such a two sides of the same coin. It's a lot of, you know, things you need to think about. Of course, you need to review most important skill coding. Yeah. But from what I'm hearing, sometimes people just tell AI, "Hey, could you do this task for me?" And it does the task. Okay, create like do everything. Create a pull request, write the description, write everything, commit messages, everything. Just go ahead, do it. And they don't do anything, and they just maybe do a little bit of testing. You can even automate testing, though. You can automate testing as well to AI. So you essentially can delegate everything to AI if you do it right. And then just, you know, do something else. I guess you could technically work on other things in the meantime if you're ambitious. And then sit on your ass, wait for it to complete. When it's done, it has the pull request ready for you. You can do it. It's possible, because I've basically done it myself. So yeah, you basically hook up to like you can hook up to like GitHub MCP, give it permissions to create pull requests, write permissions and all that. Do a code review. You can have you can write a skill that basically goes through, do all these steps, do the tests, do the like read the task, do research on based on whatever. Go ahead, implement, like write a plan to implement the task. If you must, you can create more tasks to kind of sub-step the task, and then do each one, and then like when it's all done, test the thing. You know, you can like match against some kind of code quality document or whatever, maybe some rules. Like you can do everything, and then essentially it's gonna cost a lot of tokens though, but you know, and then just create, when you're done, just do final testing, like automated tests, and maybe some, you know, manual AI tests, and then like you know, because it can even look at screenshots and stuff like that and match against, perhaps if you have a designer, it could, you know, if you have like a design document, it could look at for example, you can hook up to Figma to see that, okay, that's the design of this thing. As long as everything is like connected up, it works. And then it can like, because you can hook up to Figma as well, like Figma MCP server, it can look at the design, what it should be. And then hook up to GitHub MCP, it creates the pull request, the title description, everything is generated. It does like a code review. And even the code review comments that come in, it can also fix that as well. You're like, just tell it, hey, could you fix these? And that could be automated as well. It's like you can like, I guess you can like install like a hook for when a code review comes in, just go through it with AI and fix all this shit. Okay. And then go through the same steps, test everything and all that. And then report like, hey, now I fixed our code reviews. You can tell, like, I guess you can report directly back to the source, and then they would approve, and then it's done. So you can also auto merge. Yeah, and they're just gonna report back to you like, yeah, the task is done. Okay, let's go on to the next one. And you can even tell it's like you can hook it up to Linear or whatever your task manager is as well, like MCP up there. Get the next task. You can essentially just fully automate the whole process. The only thing you need to worry about is basically hooking up the task to the correct like data points and stuff like that. So, you know, it's possible. But yeah, you should always go in, and you should you should go in and review the code, because it's your code. Technically, it's your code. Will humans be blind to AI's execution and not see feedbacks? Wait, if you cannot understand the code, you cannot code nor work with AI. Yeah, I mean, if you cannot code, then you don't really know what you're doing if you're gonna use AI to code. Like, it can work, but also how sure are you that the system actually works? Also, thank you for the follow. Sorry, I missed the name. Let's see. Mr. Tsart, thank you for the follow. Welcome. What does, well, so will humans be blind to AI's executions and not see feedbacks? No, you should be able to, like, you can have AI like keep a log around of what it's doing. You can just instruct it to say like, hey, could you, like, when you do like a decision, blah, 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 log it in this log file. Like, you can, there's also a log, you can like watch the actual prompt log as well. When the agentic AI is doing stuff. Definitely. And if you and also if you have an AI that like Claude, that's the only issue. It's like that I see it, to fully automate this. Whenever they need to kind of execute some kind of command that it determines that this command can potentially be harmful to your computer or something, you need to press yes to run the command. That's the only like hurdle here, I would say. I wish there was a mode to just say, okay, well, I'm just gonna allow all you're trying to do here. It has never done some kind of malicious thing. But it could potentially do it at some point, you know. So I guess it's good that you have it. What does @this do in Zig? @this just means whatever type you're currently kind of in the scope. So the nearest struct that we're in. So this would be if you scroll up and you see, oh, here's a struct. This is the one that we're talking about. We're talking about this type now. So it's like a convenient way to not have to think about, oh, what was the type name again? Or having to write it a bunch of times. Or potentially if you want to move this function to another type, you don't have to change this. I really like this built-in thing, actually. Okay, I think that... What did we do, actually? I don't remember now. We have like, yeah, the number line, blah, blah, blah. We have... I think what we did was this stat stuff. Yeah. We implemented a super generic like way to get some kind of stat. So we have 3 different stats now. We have like melee damage bonus, hit value, and evasion value, which we can like sort of automatically get through this get stat function. So the get stat function will be called like this: game board stat get stat context and then evasion value. We can even put we could probably put it on context itself, actually, because it's gonna be such a common thing, probably. So like get stat, or just stat, I guess, gives us. So we need a comp times stat. This is a board stats stat. And this will be board stats stat type of stat. And we'll just return board stats get stat self stat, and self, of course, we need to have as well. There we go. Okay, so now instead of doing all this, we can just say this stat evasion value. Okay. Functions are kind of like traits on structs in Rust. I mean, I guess kinda. I have never really done Rust, but I kind of know about like sort of how traits works, because they are very similar to type classes in Haskell. And so, but I wouldn't say that they are possibly like traits. It's more like, I mean, if you're talking just about the aspect that they are. So basically, this function is just a normal function, and the self here, essentially, since we have self in the first argument of the function, and the type that we have here happens to be this type, or well, yeah, the type that is like the nearest struct. This function is now kind of seen as a member function. So you can actually say self.lance attack. Now this is essentially just syntactic sugar for lance attack self. It's exactly the same thing. These two are equivalent. You can actually call it like this if you want, but you can say self dot instead. I'm not sure how if Rust works like that, but yeah, this is the only thing that this is doing essentially. It's you're not going to be able to create a trait where you can define implementations of like an interface function or whatever on several types. It's just this only works for this type here. But that said, you can just, like, let's say you take something that is an any type. Now we don't know what this type is. It can be any type. And on any type, you can like call, you know, any function, but it has to work. Like if you call, let's say we call this function, it has to work like we say, I'm just going to put undefined in here. If I just put a number here, because you can put anything in here, now we're going to get a compiler error over here saying, you know, Lance attack does not exist on number or whatever, you know. So there you go. You can kind of like sort of have this interface sort of functions. As long as you're putting in something that has that function, then we can call it. Which is kind of what we're doing over here. This is, so what you're seeing here is a lot of like comp time stuff. It's like, it's kind of like code generation here. So what we're doing here is essentially we're looping through a bunch of declarations on a thing. And so essentially we're looping through a list of types, you can say. And we're looking at the types and we're saying, okay, do you have this method that is called some function name that we put in? Okay, do you have this method? If you do, okay, then we try to use it here. It's like, it's reflection, but it's comp time reflection. It's not runtime reflection. It's happening during compilation, not during runtime. So I'm not sure if that is technically reflection, or there's also a thing called introspection, I think. I'm not sure if that is what it's called, but yeah, you can inspect the types at comp time and like generate code based on that. So this code will not generate if the type does not have this method on it. If the type has the method on it, then we generate this code. So it's like code generation based on you know, logic that we kind of compute here in compile time. That was what zig essentially gives you here, which is really, really nice. And essentially, if I'm explaining what I'm trying to do here, is basically I have a bunch of components in game.c, which this is just a place that defines a bunch of components here. I keep all my components in here in my ECS system. And so I'm basically looping through all of these components. If I add another one, it's going to be included in that loop. So I'm looping through all the components, and I'm basically checking, okay, do you have a method that's called, you know, evasion value, or whatever we put in here? If you have a method called evasion value on the component, then we try to get the component and we call this function to get a value that we then do something with. So yeah, it's pretty cool, I would say. So for example, you know, if we go in here, like most of these doesn't have that function. So it will only be generated, that code will only be generated for the components that has the function. So for example, base attributes has the function called evasion value, which then will be picked up by that logic in comp time, and we generate code to call this function. So yeah. So it's like, I would say it's like more powerful than a macro probably. I mean, a macro would be could potentially do this, potentially. I mean, it could always be done with like code generation through like just text generation, right? Like any language, you can have code generation. But this works within the compiler itself. And it can help you compute types and stuff like that, and gives you a lot of helpers to do stuff. All right. Let's see. What are we doing? Melee attack. Did we run this and check that it works? I think so, right? I think we did. Yeah. Oh, did you see? We killed him. We killed it, but it actually got like a hit in. That's weird. You know what? I think that's because the monsters do not check if they're dead, actually. That's right. They don't check if they're dead. Also, maybe even the turn system. Actually, yeah, it should be the turn system. The turn system should not look at entities that are dead. So we're gonna skip the dead ones. Makes sense? I'm not sure if that is what the issue was, though. Okay. No, it still got the thing in. Oh, you know what? It's because they both got their turn, but I decided to attack. The player has like priority. If the player has the same turn number as other entities, they both get their turn, but the player starts to do their turn first, and then they get their turn. But isn't that the thing? Like, we should get our turn like immediately. It's like we're fine. So basically here, we're looking at, okay, everything that has a turn and is not dead. Okay, then we get all the things that has a turn. We're kind of checking if... Here we're kind of initializing the next turn at based on some stuff, but we're adding it to the list. So we're basically copying over everything, this iterator result into this result list. Then we sort it based on who's the fastest, whose turn is it next, essentially. And then we're looking at which ones have the same like turn number, because multiple entities can have the same turn number. So we're essentially getting all of those at the same time. And then we say, okay, well, if any of those are the player, if the player is in this list, then the player is the sole person, the sole character that should have the turn. So we set the first item to be the player, and then we resize the whole thing to be 1 in size, and we break with that. So that will give us the result. So that should be the player, and then next turn, it should that goblin should be dead. Actually, it should actually be dead. So I'm surprised it gets a turn in, because it should not get. Yeah, it should have the dead component. Huh. Wait. Did it get the dead component? Okay. Now health is an I32, so it can be less than 0. There we go. We have to check. So it didn't add the dead component. Interesting, but it still kind of disappeared. That's strange. Okay, now it doesn't attack when it's dead. Okay, cool. Right, because everything is turn-based, so when the player does an action, that action has technically, like, should already affect the board state. Yeah, so now it doesn't attack. Cool. All right. Yeah, so we don't really need to do anything here to check. We just need to check if it's our turn or not. We don't care if we're dead. They could lead to some issues later, maybe. I guess maybe like if... No, as soon as you do an action, like the state machine essentially is just like... The job is essentially just to create an action immediately. Maybe change the state based on the current board state and then choose an action essentially. Yeah, but it should always end up doing an action essentially immediately or the frame after or something like that. Determining the action and then it's done. Because then it's no longer its turn. Yeah. Okay. Okay, so what do we have now? Oh yeah, so we did, this was the last thing we did. We refactored this to, now you can just say like that to get the stats. Cool. And why is this convention like this? Why is it like this? There we go. Cool. All right. So this project, we have state machines. We have what's it called? ECS. We have event system. We have like a turn-based system. We have a animation monad. And then also a very generic way to get like the board stats and stuff like that. A lot of different ways to do things essentially, but for different purposes. Okay. I especially like this system here. Really, really nice to work with. All right, but I think that's gonna be it for this time. I need to eat stuff, and how long have we been here actually? Like the tags here are a little bit weird. 3 hours. Yeah, but I'm getting a little bit of a headache here. So that's gonna be it for this time. But thank you very much for watching, and we'll continue this next time. I will send you off somewhere. Wait, we should search for zig, even though it never shows up anything, right? Zig is the best. Zig, can we just do that now? Because there's like a, sometimes people put large capital in the beginning. I'm looking at the tags mostly here. You want to say this? Code, vibe coding? Code with AI? I mean, you might learn something. No, just kidding. Board check. Ah, board check. Why is the search so bad here? All right, there we go. Let's go. Let's go. Let's go. Have a nice day. See ya. See ya.